Hi, in this video I'm going to introduce the normal model. All right, so the characteristics of a normal model is, as you see the curve below, also known as a bell curve, is that it is symmetric and unimodal. In the middle, right here, the mean is right, divides the graph symmetrically. So if you were to fold it, half would fold over, they would overlap. And the mean, the median, the mode are the same. So we would have the mean right here at the center. All right, the next thing is that the area under the curve adds up to 1 or 100%. And we use the symbol capital N for normal model. Mu is the mean right here. So this represents your mean. And sigma represents your standard deviation. So sigma right here is your standard deviation. Now this is population symbol. So these are Greek letters that we use for the normal model with a mean mu, comma, sigma. Let's go ahead and see what else. All right, so we also know from the normal model that we have something called the empirical rule. What that means is that 68% of the values will fall within one standard deviation of the mean. 95% of the values will fall within 2 standard deviations of the mean, and 99.7% of the values will fall within 3 standard deviations of the mean. So what does that mean? If I drew a normal model, I'll try to make a curve like this, and we would have an x-axis. Then if my mean is right here in the center, so this is my mean right here. So 1 standard deviation to the left and 1 standard deviation to the right would represent 68% of your data. So this is always true for a normal distribution. All right, so looking at the normal model, we have our mean right here, mu, and sigma represented by the symbol here. This means 1 standard deviation to the right and 1 standard deviation to the left. So it is approximately 68%. We know for a normal distribution such as this model that about 68% of our data is 1 standard deviation left and right. So this is 68% right here. And 2 standard deviations means to the right and to the left. So 2 standard deviation would be represented by what I am drawing here. And you could see our mean in the center at 2 standard deviations to the right, 2 standard deviations to the left. That is considered to be about 95% of the area under the curve. So when I say percentage, I'm talking about the area under the curve. And 99.7% is 3 standard deviations. So from left to right, we have 99.7%. So that is our empirical rule, and all normal models will follow this rule. So again, 1 standard deviation from the mean is 68%, 2 standard deviation from the mean is 95%, and 3 standard deviations from the mean, meaning left and right, is 99.7%, approximately. All right, so how would we build a normal model if we were to be asked to draw and label normal model? In this case, we're given capital N, that represents our normal model. This is right here our mean, and this is our standard deviation. So of course, this is not in context right now. We are not told what this is, but normally you would be told what your distribution represents. So let me go ahead and draw. This pen does not work. I'm using my mouse. This is why it is so slow. All right, so what you would want to do is draw a normal model. So to the best of my ability, I'm going to draw a curve that looks something like this. And one more thing I want to talk about are the tails. So I'm going to draw an x-axis. Okay, so my normal model is this. So the first thing I'm going to do is I'm going to put my mean, which is 50. So I will write down 50 right here, which is the mean. And then I will add 10 as my standard deviation. So approximately one standard deviation to the right is 60, because I'm going to just add the 10. And then 2 standard deviations would be 70. So I just keep adding 10, and I do it for 1, 2, 3. This would be my third one. Now, if you were to draw it, you kind of want to put it at the point of inflection right here. So it is a sketch, so it is basically where you see a sharp kind of change in the curve. That's where your standard deviation would go. So I have 1, 2, 3. All you need to do is do 3 standard deviations to the right. I'm going to do the same thing on the left. So approximately here, this would be 40. And I'm just going to keep counting 10. So right here, I'm going to say 30. And then one more. This will be 20. So we are not done yet. So far, I drew my model. I put the mean in the middle, which is 50. Standard deviation 10. So I counted 10, another 10, another 10. So basically 3 on the right. And then I'll do the same thing to the left. 10 to the left, another 10, and another 10. Now, what do I also want to show? I want to show that 68% of my observations are always going to be 1 standard deviation left to right. So in other words, this represents 68% of my data. And then I could go ahead and put in 95% of my data. 95% of my data is going to be 2 standard deviations from the mean. So it would be between 30 and 70. So 2 standard deviation from the mean, that would be 95% right here. So I will write it here. Hold on. Let me write it here. 95% of your data is 2 standard deviations away. And then, as we mentioned, we have 99% of the data. So we can say from here to here is 99.7%. So 68% of your data lies between 40 and 60. 95% of your data lies between 30 and 70. And 99.7% of your data lies between 20 and 80.